morning, ladies and gentlemen. Very good morning to Mr. York and the team, and also for all of you just come in this room. So today is the second day of our biomechanics and physiotherapy seminars. And yesterday was very interested that we have a lot of things that we have to learn, and we have to practical later, and to practice how to set up the injured athlete and how to avoid, how to maintain, or how to make sure that our athlete can come back after injury. So I think the second day will be more interesting because we have biomechanics subject. So here, Mr. York will be with Ms. Rachel Tan. So please, the Zoom is for you, York. Thank you very much.
Looking forward for our second day, and what I realized yesterday, we cover a lot of theoretical stuff. Sometimes not so easy to understand all the things. So we change a little bit today. In the morning, we are doing some biomechanical, call it basics, especially for track and field, what you can do, how actually biomechanics and testing work together, because this is quite important for us, especially as coaches and physios as well. You've got a new clue and view what you can do with your athletes, and you understand much better. And in the second, from 2 o'clock to 4 o'clock, we do testing, and then how we create actually a training schedule for our athletes. So how the tests can help us to create a good program, how we do that. And I have my stuff here, so we're doing this step by step, very slowly, that everyone can understand. We are doing a lot of exercises as well, and of course, what we call it basic and strength training, what you have to watch, what you can do, etc. We are going forward to this. Yeah. So, oh, Miss Ria, you want to say something because you're in my line picture. Oh, now it's me.
No, I do not.
I was a mistake.
I do not know why I'm doing.
Okay. So this is the plan, and also don't worry. Every time you have some question, write it down, bring it up later, send it to me. I will happy to answer you all the stuff. Yeah. Okay. We don't want to wait so long. We will start a little bit different from yesterday. I was looking around to check how is it for you to understand biomechanics easily. And there was a very nice video done some couple of years ago with one of the best high jumpers, with Stefan Holm. And please enjoy the video. Unfortunately, it's in German, but with English subtitles. So no worries. I will be here and I will translate some stuff as well. Yeah. And after the video, I will introduce you to my young colleague, Rachel Tan, and she will do all this stuff for the biomechanics. So enjoy the video, and then you realize how simple is actually biomechanics. Okay? Enjoy. How high is 240? (59 centimeters over his body height. He's 181. It's only training, but everything is very focused on. You have a very high velocity in the run-up. He's running 30 kilometers per hour. Now we're coming to the takeoff. My feet.
Okay. តូតកពស់ខ្ញុំឈប់សិនមានផ្លូវឲ្យមានទីសាសហ្នឹង
Okay, so you realize how simple is actually biomechanics when you know the basics. Yeah, and you see Stefan Holm is only 150, 81 and he jumped at 2.40 meters. What you realize, he was extremely fast, have a perfectly take off, and have a very good technique. So these three components have to come together, and then you will see, yeah, you can do it. So I will give to my colleague. She will be here now for the next 45 minutes to 1 hour. Yeah, I know Rachel for a long time already. So she was my student and now she's my colleague. So I'm quite happy. And yeah, you do it here.
This is my notes.
Oh, okay, cool. So come here, Rachel. We all want to see you. Enjoy, ladies and gentlemen. Rachel is here.
Hi, everyone.
Welcome, Rachel. Hi.
Oh, thanks. My name is Rachel, and I have been working with York for quite a while. So York usually does all the injury stuff, and I usually do all the biomechanics stuff. So now we're going to fuse both together so that we can understand how biomechanics and injury work together. Okay, what do I do now?
You ready, sir?
Yes. Okay, so like I mentioned, we'll be learning about the biomechanics in track and field and how it relates, how you can use it to prevent, assess, and sort of minimize injury. So what we are going to learn today is to understand factors influencing muscle force production. So we're not going to learn all the factors, we're going to learn the most important one, I feel, that can be related to injury and rehabilitation. We're going to learn the importance of testing, how testing can prevent and assess injuries, and of course performance, to be able to conduct the test correctly, accurately, consistently. So because it's a test, everything has to be consistent, right? And we're also going to learn how with this test we can see what areas of the body is weak, where there are muscle imbalances and stuff like that, and also of course to understand the and its role in injury prevention. So biomechanics is basically the study of how the body works and how it reacts to the environment around it. So whether or not it's how you are walking on the floor, how the floor ground reaction force reacts to your body, whether or not you are running or driving, how the surrounding reacts to whatever force is going on within your body and around your body. So most of the time, in terms of human biomechanics, sports biomechanics, we always incorporate anatomy, physics, kinematics, and kinesiology. And of course, because this is about injuries, we want to talk about how the musculoskeletal system functions in different conditions and different situations. So I'll give you an example. Biomechanical abnormalities of the lower extreme. We always associate it with ankle injuries, knee injuries, hip injuries, lumbar-pelvic injuries. So in track and field, obviously you use your legs a lot. So we definitely have to prevent injury on those parts in particular. So sports biomechanics, to go more in depth, is obviously a branch of biomechanics. And it studies why and how the human body moves in a given environment. So for example, it's like a gymnast balancing on a beam and she's doing all these interesting little stunts, flipping all around and not falling down. So that's how her body is reacting to the lack of surface to stand on. Or it could also be a thrower throwing a javelin. So there are different aspects of biomechanics where it's kinematics, kinetics. So basically, you can study the biomechanics speed of the javelin or the angle or how the javelin travels. You can study the biomechanics of how the wind affects the javelin, or the biomechanics of the athlete himself, how he reacts to the ground reaction force, how he moves around, the kinetics and kinematics of the thrower. So for a fun fact, the difference between kinetics, which is this, let me just erase it quick. Okay, so kinetics is the study of forces that are acting onto a particular mechanism, whereas kinematics is a branch of mechanics that is concerned of the motion of the object without the reference of the forces which cause the motion. So to put it simple, kinematics studies the description of motion, whereas kinetics studies the explanation of motion. Right, so the importance of why you have to learn the biomechanics in track and field is so that, of course, number one, it improves performance. So you can do testing, you can do biomechanical analyses. So testing, when I put testing here, I mean as in performance-wise testing. So maybe like a maximal one rep max. Oh, thank you. 1 rep max strength test, or you could do a jump test. And in terms of biomechanical analyses, it could be how your body moves within the jump test. So maybe one person, when he lands with a foot more out turn, stuff like that. And it also allows for optimal performance while being energy efficient. So if you run wrongly, or if you jump wrongly in high jump or whatever jump event you are in, you are wasting unnecessary energy that can be put into giving you that extra distance that you really want to achieve to win. So with biomechanical analyses, you can see all the wrong techniques that have been going on. And then there are types of biomechanic devices, softwares and stuff currently that they give biofeedback. So biofeedback basically means being able to see there and then what you are doing right or wrong. So a lot of times when someone has run and you tell them, oh, as you are sprinting, you are sitting down. Okay. So you don't want to be sitting down that you may not understand, as opposed to if you show them, okay, look, this is your body, it's bent down too much because you're sitting down too much, then they may be able to understand. So you need to also remember that there may be a given standard technique that everyone uses, but because we're all born differently, we have different muscle lengths, we have different limb lengths, we obviously have to work around it, tweak things here and there. So what the normal eye cannot catch, at least you can catch with all these new biomechanical technological advances. Of course, we also want to learn about injury prevention. That's why we are here. So what I want to touch on for a little bit is the importance of biomechanics in injury prevention, because knowing about injury prevention is not enough. You need to understand the biomechanics behind it. So the common knowledge for injury prevention is that, oh, okay, if we overtrain, we could get burnout and then we could get injured because we're all tired. Yes, that's nice to know, but it's also nice to know how biomechanics can relate to prevention of injury. So basically what we're doing is we want to understand the common, you need to understand the common injuries within a sport. So track and field, you have a lot of lower limb injuries, like I mentioned. You've got like shin splints, you have hamstring strains, especially for sprinters, ankle sprains. So it's important to know how the injury was caused, the biomechanics of the particular limb and joint. So especially for physiotherapists, if you don't understand the biomechanics of these limbs, you may prescribe ineffective exercise. So you might be wasting time giving exercises that are not as helpful. It may not be a wrong exercise, but there are more time efficient exercises that you can use. That's what I'm trying to talk about when it comes to optimizing speed and rate of recovery. So you also minimize the aggravation of injury. For example, if let's say you were to assume that ACLs and PCLs, which are ligaments in the knee, are the same, you might be giving someone with a PCL injury ACL exercises and you'll be aggravating the injury. I mean, obviously they are both in the knee, so logically, if you don't really understand it, you'll be like, yeah, it's all in the knee. I cannot give them all the same exercises. No, it doesn't work that way because, for example, ACLs, they limit forward tracking of the tibia, whereas PCLs limit backward tracking of the tibia. So if you don't understand that, the injury could make it the injury could get worse tenfold. It also determines risk factors towards injuries. So this is in terms of testing. When you do a test, if you see a particular red flag in a number or a particular movement that is a risk towards an injury, at least you can minimize that. Of course, you can prevent injury, which is what all rehabilitation experts should be aiming for. Because once you know the cause of the injury, if it is in fact caused by, let's say, muscle imbalance or weakness in a particular muscle, at least you know that you have to work on that more. And it omits and minimizes unnecessary stress onto the body, which you can somewhat relate to the previous slide, which I was talking about, optimal performance while being energy efficient. Okay, so what I really want to touch on is the length-tension relationship of the muscle. This is quite important, especially if you want to optimize performance. So these are myofibrils, which is the actin and myosin. So what the length-tension relationship is trying to cover is that, okay, so I'll explain point by point so that it's not so confusing. So it represents the static capability of a muscle and indicates the force. It indicates the force that muscle can exert at different lengths. So, for example, if the overlap between actin and myosin is too much, when you want to contract, so this is your actin and myosin, and you're trying to contract it. If the overlap is too much already, not as optimal, there's not enough space for the actin and myosin to overlap even more. So the force production is lowered. So, and then if, let's say, the overlap is too wide, there is not enough space for the actin and myosin to actually grab onto each other. So then also the force production and the tension is lowered. The muscle force varies in proportion to the amount of overlap, so which is what I was trying to explain. So the first one, A, the overlap was too much, and the one in between B and C over here, the overlap was not enough. So the muscle tension obviously varies according to its length. If you have a shortened muscle, there is not much tension already. So when you have a shortened muscle, it's important to know that you have to stretch. So in terms of applying a quick stretch to the muscle, which is known as the stretch-shortening cycle, which I will cover literally right after this slide. When you apply a quick stretch to the muscle, you can generate additional force. So for example, if your muscle is already shortened, you lengthen it a little bit, so give it more space for the actin and myosin to grab onto each other. It can recruit more connections and produce more force. So the reason why I included this slide, the main reason why I included this slide, is to make sure that you understand that shortened muscles in fact do produce less force, but it is not to be confused with tight muscles. So tight muscles, they are not necessarily shortened. Tight muscles are already in contraction. So by stretching tight muscles, you may or may not aggravate it even more. So the goal is to actually release the tight muscles first, but because I know that a lot of people always confuse shortened muscles and tight muscles. So before I go to the next slide, I need everyone to remember that when a muscle stretches, so in terms of the stretch shortening cycle, when a muscle stretches, you store energy. So that's why you want to stretch the muscle when you do like a counter movement jump. So when you're standing up and then you go to a squat and you jump, you're stretching the muscle to store energy, and then it's quickly converted into power. So the difference is that counter movement, you have the stretch. squat jump, you don't have the stretch. So there is no there is no energy storage to convert into power. So the stretch shortening cycle is due to a combination of recovery of stored elastic energy from the muscle. So elastic energy meaning the initial stretch that you do from the counter movement jump. So when the muscle is actually being stretched, negative work is being done into the muscle. So energy is being absorbed and stored. That's why in any form of jumping, even short putt, you don't just stand there and you throw it. You go back, you rotate. So different events, you have different means of storing the energy. So the goal is that you want as much elasticity as possible into the muscle. So you don't want your muscles to be stiff. You don't want it to be tight. You want it to be as springy as you possibly get. This allows the muscles to stretch and absorb energy more efficiently. So if you do not have the elasticity in the muscle, you will not be able to get that springy action that you want so much, which I'll explain a little bit later if I'm not wrong. So on the topic of elasticity, right, you have to actually be efficient in stretching in order to be more elastic, which means you have to be more flexible, obviously. So the effects of stretching that you actually do is that you increase the muscle flexibility and the ability to store energy. It also maintains and improves the range of motion of the joint, which is what you want for most events. You want that reach that the joint can achieve. And you also increase the elasticity and length of the muscular tendinous units, which goes back to being able to store energy more efficiently. So when an actively tense muscle is stretched right before a contraction, the result of the contraction is more forceful than in the absence of a pre-stretch, which we'll explain later when we compare a counter movement and a squat jump. Alright, the pattern of eccentric contraction, which is the absorbing, followed by immediate concentric contraction, that is what is known as a stretch shortening cycle. So if you actually manage to convert energy efficiently with the stretch shortening cycle, the metabolic cost of performing any mechanical work is much less compared to if you do not give Alright, so this is the springy action that I was talking about, the ability of your muscles to convert potential energy to mechanical energy. So it's like a spring. If you squish a spring down, it will bounce back even more quickly as opposed to just leaving the spring there. So if you stretch the spring, it'll shorten better and go back to its original or even better.
Sorry to disturb you, ma'am. Sorry to disturb you. Could you please explain last slide once again, please? We could not hear.
Which one? Okay. Sorry, this one.
Last, yeah, please.
Okay, yeah. Which part of it did you want me to explain better?
Starting was it was a disturbing slide. That is the reason. Sorry.
Okay, all right. So basically, what I'm saying is that, okay, so imagine if you had a short putt, right here in front of you. And I asked you to leave your hand here at this height, and I asked you to just throw the short putt. As opposed to having a short putt here, moving your hand backwards and then pushing it forward. So the action of pushing it back forwards and pushing it forward more front is going to warrant a further distance in short putt, yeah? So does that make sense? Makes sense, right? Can you hear me?
Yeah, we can hear. We can hear.
Yeah, okay. So the action of pulling back your hand, you are actively tensing your muscles to stretch right before a contraction, which is the pushing motion of the short putt. And the resulting contraction is going to be more forceful as opposed to you keeping your hand here and just pushing forward, because you're not absorbing any energy to store. So that pulling back is an eccentric contraction, and pushing forward is going to be a concentric contraction. So that action is known as the stretch shortening cycle. Now, when you do that, you would not have to put in so much force to push the shock part forward as opposed to keeping it here. So keeping it here is raw strength. All you have to do is put in your maximal strength effort and push it forward as opposed to pulling it back. You do not need to use your raw strength to achieve the same distance. So far so good?
Yeah.
Yeah? Okay. So, okay. We're going into the analysis, the biomechanical analysis part of track and field now. So I'm only going to cover gait and I'm going to cover jumps because these are the few more important aspects of track and field. So the importance of gait analysis is obviously you want to improve your performance. So you want to increase efficiency. You don't want to waste energy doing the wrong action. You don't want to waste energy contracting the wrong muscles. And you also want to find a proper technique for each individual. Like I said, everybody is different. So everyone, do I have to do something about that? If someone raises their hand, what do I do? Kevin. Oh yeah, what are okay? Give me 2 seconds. There's so many things popping up. I don't know what to do. Right. What is all these things? Do I have to do anything about it?
No, actually no need.
Because apparently there are people in the waiting room. Why is there a waiting room?
But I mean, like.
And then it's like someone raised their hand. What do I do about that?
Okay, you can continue.
Okay, where was I? Yes, you want to find a proper technique for each individual because some people are born with shorter muscles, some people are born with longer, some people are born with different limb sizes, different limb lengths. So you want to optimize performance for each individual. You can't force every single person to do the same exact thing. And of course, you want to use it as an injury prevention. So if someone has been using the wrong technique for that individual, you may warrant a higher risk of injury, maybe through muscle imbalance, muscle tightness, muscle overusage. And like I said, if you use cameras, you'll be able to find imbalances within the body. All right, so a gait analysis basically is a pattern of movement that a person uses to walk or run. So that is your gait. And to analyze the gait is to identify how somebody runs and how somebody walks, whether it's good for them or bad for them. So there are techniques. So one, you'll be using gait analysis for technique. So you'll be assessing the technique of a person. Another one, you'll be using gait analysis for cues and red flags to look for in terms of risk and injury. Why is it not? Yeah. Oh God, what have I done? It's not. There we go. Okay. Hang on. Let me just pause it. Hang on. Okay. So I'm going to show you a quick video of gait analysis, and then I will talk more about it after the video. I don't know how to play it. Nope. How do I play it? I don't know. Hey. There we go. Can I fast forward? Yeah. Okay, that's lame. I'm quarter with you.
No, they do.
Okay, is it done? All right. Okay, so that's just walking. Obviously, we don't really do much walking in track and field except for what is that? I guess the race walking, yeah, speed walking even. Even then, the mechanics are different. But it's important to understand that if you don't understand walking analysis, you may not be able to understand running analysis. So the two differences between walking and running is that when you are running, especially sprinting, there is an absence of a double limb support. So you'll be able to see it here somehow.
You upload the video.
Yes, I did. You were the one that uploaded the
You
video.
uploaded.
No, or maybe it's the next slide. Oh, there we go. Okay, so you can see in this video there is an absence of a double limb support. So that is your flight time, your float period. So when it comes to running, you will have a float period which walking doesn't have, and you will have more hip and knee flexion and extension. So now the new stance to swing ratio has been changed from 60-40 to 35-65. So I want to show you over here. All right, so this is the analysis of running, right? So now you have obviously you have a float period and a late float period where you did not have at walking. So basically you'll be flying. And the ground contact will be much shorter when you start running as opposed to walking as well. And you have a few different phases. So here you only have actually 4 phases as opposed to running where you have, as opposed to walking where you have 6. So what you have to focus on when you're doing a running analysis is the initial contact of both legs, obviously. So you start with the first leg, right? And then you want to watch the toe off. You want to see how they land and how they push off. And you have to compare it with the left and right leg. So I think in the next 2 slides, I'll show you a comparison that I made on an actual person. So I want to highlight on the energy source in terms of walking versus sprinting. So this energy source is not as in glycogen storage or stuff like that. This energy source is as in mechanical energy and force output. So even though the energy source for the ankle is decreasing over as you increase the speed, you can still see that the energy required for the ankle is much higher compared to hip extension, flexion, abduction, and the energy required in the knee. So keep in mind that the ankle is one of the smallest joints in the lower limb. It has the smallest muscles and a lot of ligaments that could potentially be torn. And injuries to the ankle, to me, particularly are more crucial compared to injuries to the knee or the hip, because when you injure the ankle, your gait changes. And once your gait changes, whether or not you are running, whether or not you are walking, it will impact the mechanics of the knee and of the hip. So if you injure your ankle and you don't get it fixed, you might as well have injured your knee and your hip as well. So for example, constant impact on the medial side of the ankle could potentially cause medial knee pain because the force is already going through the middle of the ankle. When that happens and you don't get it fixed, the worst case scenario is that over time you could definitely cause meniscal or cartilage damage. So this is what I'm talking about in terms of the ankle. So there are a few actions of the ankle, but in terms of running, there is overpronation, supination, and of course the neutral position. So these types of pronation is determined by the arch, like the condition of arch of your foot, whether it is high, flat, neutral, or collapsing. So there are different types of running, whether you land in supination, overpronation, or neutral. You may have to resort to different types of shoes and exercises to prevent injury. So the first one I'll talk about is overpronation, where most of the weight is pushed towards the medial side of your ankle. So it's the most common type of foot planting when it comes to running. So this is mostly due to flat feet or a low arch or an arch that is collapsing. So you may have a high arch, or you may seem like you have an arch, but when you do this test and you see that you are overpronating, it could be an indication that your arch is in fact weakening and collapsing. So at least it gives you an idea of what you have to do to prevent it from fully collapsing. So when the foot is planting, like I said, the weight is transferred more medial, which means that for the knee and the hip, the weight is also transferred more medial. So upon push off, there is more activation on the lateral side of the calf because you will be pushing off with your toe, with the big toe. So when you push off with your big toe, you activate more on the lateral side of the calf. Then only one side of your calf gets tight. So you will have tightness on half a leg and the other half is fine. When the other half of the leg is fine and this side is tight, over time, this will start to overcompensate. So this side is going to get injured through tightness and this side is going to get injured through overcompensation. So how this can be helped, obviously one is shoes that assist with stability and have an insole. Insoles may not be as comfortable for those running, especially sprinters, and you hardly ever find insoles for sprinting shoes. So there are exercises that you can do. You have to control the collapsing of the arch or increase the arch. So if you keep it like this forever and you say, oh, okay, this hasn't actually caused me any problems, I don't want to change my regime, I don't want to change my running style on my shoes, you could actually be at risk of medial knee pain, medial ankle pain, higher risk of RSIs, which is repetitive strain injuries, and of course, a higher risk of ankle sprain. So the ankle sprain that you could potentially be at high risk of would be the medial one, which is more difficult to fix than the lateral one. So another one is supination, which is basically shifting the weight more lateral. So it's the opposite of overpronation. Hang on, give me 2 seconds. Okay, so so this one, the weight distribution is more lateral. When you run like this, your weight would shift more, so your whole body, basically from the trunk to your head, would shift more laterally side to side, which then will warrant more energy usage and then make you more tired. So it's not as efficient for you to run in supination because you're wasting a lot of energy. So this is usually caused by high arch and also obviously cause lateral knee pain. So upon push off, there will be more activation on the medial calf because you're pushing off on the lateral side of your toes, which also obviously warrants higher risk for repetitive strain injuries and ankle sprain. So the ankle sprain that you may get if you land too much in supination is lateral ankle sprain, so which is your CFL and ATFL. That one, even though it is easier to fix than the medial one, of course you want to avoid getting injured that way. So this one is neutral, which is the ideal foot strike when you are running. So the weight and force distribution are equal on both sides, so both sides at the calf, and the impact that your your ankle joint, ligaments within the ankle joint have to absorb is more equal on both sides. So this is the ideal way of running, and this is obviously warrants the lowest risk of injury. So this is what I did. I did an analysis on a runner a while back, and he seemed fine walking. Then I increased the speed to 8 kilometers per hour. He seemed fine as well. So this is the speed of him running at 10.5 kilometers per hour. Okay, so I compared 10.5 kilometers per hour on a slope and on flat ground. So this on flat ground, he ran like this. Both sides of his leg was like this. But on a slope, on his right leg, his right leg, you can see that he was more overpronated. When I checked, so after the analysis, when I checked on the condition on both his feet, his right foot was actually slightly flatter than the left foot. And when I asked him if it's always been like that, he explained to me that he actually did sprain his ankle a year ago, and then he noticed that his foot got a bit more flat over time on the right leg. So when that happens, so when you sprain an ankle, your arch will weaken because you're not using your foot because you're in a brace. So when the arch weakens, it starts to collapse. So like I mentioned in the previous two, when it starts to collapse, you actually want to do some exercises to actually increase the strength of the tendons supporting the arch. All right, another high-risk injury for running is hamstring strain. So the more you increase your running speed, the more hip extension, the more triple extension you will have to engage. So if you don't do that, obviously you're not going to go very far. And with the additional increase in hip extension and triple extension, the length of your hamstrings are lengthening. It's producing its maximal force and performing negative work. So when I talk about negative work, it's basically eccentric muscle contraction as the muscle is working with resistance, because you stretched out your hamstring. Okay, you have already stretched out your hamstring over here, and you're trying to push your body forward, and
Is it any problem? Because we can't hear. I can't hear anything.
I think they stop. We wait for a while. I think they lost of connection, so I think we have to wait. Yok, are you here? I think they are not here, so we have to wait for a while to take another connection for them, for the presenter. I think they got a problem with connection in the office.
Yeah, we think so.
Nadia, can you WhatsApp Yok what happened in this office?
Yeah, Kevin just sends message that there is a wrong, something wrong with the internet, and they are reconnected again.
Okay.
They will be back soon, Pak Ria.
Okay.
Maria. Itu
Ya Pak Dwi,
TLS nggak ada yang datang ya?
TLS nggak ada.
Maldives juga nggak ada.
Ada dua.
Siapa yang Maldives?
Hanim Muhammad, Hussein Halim.
Okay, we will welcome to the speaker. You're already here. So I think the short time. Yok, are you here already?
Oh, no.
Still not yet.
Hello.
Yes, we can hear you now.
Okay, cool. All right, so where did I leave off?
Okay, yeah. It's okay. Actually, you can start again.
Where because I cannot remember where I started.
Hello?
Okay,
Hamstring. It's coming to the hamstring now.
Hamstring. Okay, hamstring. Cool. Not that far then. Okay, here, right? Is it here?
Yes.
Yes, correct.
Okay, cool. Okay, should I start from the beginning?
Sure, please.
All right, I'll start from the beginning. All right. Okay. So, the faster you increase your running speed, the more you require hip extension. So more hip extension equals more torque when you swing your legs. So when your hamstrings are lengthening, so this part here, the right leg on this stance, terminal stance here, your hamstring is producing peak force at that time and performing negative work. So negative work is the eccentric muscle contraction that is going on within the hamstring. So when your hamstring is lengthened at that degree and there is so much negative work going on, the chances of hamstring strain actually increases. So you need to understand that the mechanics of the hamstring is very important in running. So a strong hamstring is important, but in order to have a strong hamstring, you also need to have strong glutes because the hamstring and the glutes work together. If your hamstrings are strong but your glutes are weak, nothing is there to help drive you forward. So then, of course, you also get a hamstring strain. So hamstring, glutes work together. Very important. And you need to understand that the strength in glutes, 3 glute muscles, didn't include here. You have to focus on the glute maximus because glute maximus helps with the hip extension. Okay, now we've covered running. We are going to go to jumps. So later there will be a practical demonstration on jumps. We're going to do the theory first. Try to remember as much as you can and then apply it back into the practical when you learn it later. So you're good. Obviously 2 types of jumps, right? So there's vertical jumps, there's horizontal jumps. So the 3 types of vertical jumps that I want to cover today are counter movement jump, squat jump, and drop jump. These are one of the very few important jumps that can be translated into track and field. So the first one is counter movement jump, where you start standing tall, and when you queue for someone to go to start the jump, you squat down to about, ideally you want it to be 90 degrees, only because, you want your thigh to be parallel to the ground, only because when it comes to testing, all the small little things have to be the same. So the angle has to be the same, the tester has to be the same, the platform has to be the same, the timing gate used in whatever test also has to be the same. So to keep everything the same, ideally you want the thigh to be parallel to the ground. Of course, it's not possible for everyone, so you have to keep that in mind. And then, as I was saying, stand up tall. When you cue the person to go, immediately go into a squat and then immediately jump up and land softly, obviously. You don't want to land hard because then you could injure one of the 3 limbs here. So the cue to conduct the counter movement jump is to look straight, arms akimbo throughout the test. So arms akimbo means hands on hips. Go into a squat approximately 90 degrees at the knee or parallel thigh to the ground, and immediately, as fast as possible, jump straight up and achieve maximum height. And then you land with both feet on the contact mat, pressure plate, ground, whatever it is you're using to conduct the test. So counter movement jumps can be used to measure the individual's lower limb explosive power. It can be used as an exercise, obviously, or as a test. And the counter movement jump utilizes and maximizes the stretch shortening cycle, which I was explaining just now. So the reason why this counter movement jump maximizes the stretch shortening cycle is because you maximize the eccentric stretch going down, and then from that energy storage in the eccentric stretch going down, you convert it immediately into power as you jump up. So the application in track and field obviously is in jump events, sprinting, and throwing events. So it's pretty much all the events. So there are a few phases that I want to cover in terms of squat counter movement jump, which is the weighing phase, which is also known as the silent phase, where you're just sort of standing there, hands straight. So this is the weighing phase, not doing anything. And then you go to the unweighting phase, which is this part where you're going down, you are absorbing force. So at this part, the ground reaction force is actually lower than your body weight, which proves that you are in fact absorbing force. And the braking phase, which is this part where you're jumping up, because you are pushing against the ground, you are increasing the ground reaction force, so it is more than your body weight. And then in your propulsion phase, which is here, it is even higher than in the braking phase. So the ground reaction force is most likely at its highest. And then of course, when you reach your flight phase, which is where you are in the air aerial, there is no ground reaction force because you are not in contact with the ground. So the ground reaction force is 0. And then in landing, it is definitely going to be much more than your ground reaction force, because your body weight plus gravity is landing down onto the ground, which is the collision part. So far, so good? Oh, okay. Now we're going to talk about squat jumps. So squat jumps, there are a few cues in squat jumps. So squat jump, comparatively to counter movement jump, you don't actually start standing up. So in the counter movement jump, this is your starting phase. in the squat jump, this is your starting base. You're already starting in a squat. So the cue is that you start someone in a squat, arms akimbo, which is at your hips. You have to hold the squat for 3 seconds, so at least 3 seconds. So this 3 seconds limits the, this 3 seconds helps the energy absorbing into the squat dissipate. So you are trying to omit the stretch shortening cycle. You don't want to absorb any form of energy. And then from this position, you're going to jump straight up without counter movement. So the most important thing to remember in this jump is that you do not want a counter movement. And then of course you land with both feet on the pressure plate. All right, so the phases in the squat jump, which is the quiet phase, which is this one, is very, very important because this is the main difference between counter movement and squat jump. So when you do a counter movement and a squat jump, I will explain later here, there will be different results that explain different aspects of the jump. In the propulsive phase, it is a concentric only phase. So in the counter movement jump, it was an eccentric and then concentric test. For squat jump, it is only a concentric test. So you're testing the raw strength power in someone's jump, as opposed to this counter movement where you are testing the raw explosive power of someone's jump. All right, so this is the cue for the start of the squat jump. You want 90 degrees here, so thigh parallel to the ground, and you want your body to be 45 degrees up. So ideally, you want to start everyone like this. Of course, if someone cannot actually achieve this stance, you have to tweak it a little bit for the individual. So when you conduct the test for this particular individual, you have to use the same exact measurements that you used before, because if you change it, then the results are pretty much useless. All right. Okay. All right. So, wait, I've already talked about this, haven't I? Yes. You want to keep the test as consistent as possible because you don't want results to change. So when it comes to the cue for landing and for jumping, what you want to see is when somebody lands, you want them to land with their knees. Do I have it? Okay. You want them to land with their knees above the ankle. So they are in line and of course not crossing inwards like this. So this one, you are already having internal rotation. So you don't want any internal rotation going on when you jump, or when you land, sorry. So the way this particular participant is landing after a jump can determine what type of muscle imbalance this person has. So if you go back to anatomy, you have your glute medius and your glute minimus, which are responsible for controlling external rotation of the knee. So because this person landed like this, you can already tell that the glute med and the glute min are not strong enough to pull the knee into external rotation. This landing
Disappear again.
Again gone.
Okay, we have to wait. I think the connection over there is very bad.
Basically, they have an Independence Day, that's why.
Yeah. Okay, so we have to wait for a while. Or maybe you want to do presentation, Rafiq?
No, sir.
For 5 minutes.
I can say hi back.
Hi again.
Okay, you come back. Great.
Yeah, the internet doesn't really like me today, so. Yeah.
Then that's it.
Okay, shall we go back to where did I stop?
Don't you know where you stop?
I don't. Well, where did I get cut off?
Yeah.
Here. Okay.
Yeah.
Shall I start from
Correct,
the?
correct.
Okay. Do you want me to start from the beginning again, or okay? I'll start from the beginning again. Yeah. All right. All right. So when you land like this is internal rotation of the knee. You do not want internal rotation of the knee in any form of landing. Single leg landing, landing from a hurdle. When you're running in a hurdle and you land on that after one jump over the hurdle, one leg on the ground, you do not want the internal rotation of the knee. So by doing this jump, you can actually see if there's an internal rotation of the knee. And what the internal rotation of the knee means is that it could potentially mean that your glute medius and your glute minimus are weak. You have to probably work on them. So glute medius and glute minimus, they work together for external knee rotation, but glute maximus is hip extension. So they're different. You need to remember that, yeah? And to land properly, ideally, you want the knees to be right above the ankle. So it's either the foot is here or the knee is here. Either way, as long as the ankle and the knee are in line, you're good. So where was I? Okay, that's all. Now we are going to compare the differences between the results you get from counter movement jumps and squat jumps. Oh, thanks. I want you guys to keep this one in mind, keep this landing in mind, and keep the differences between the two jumps in mind. So like I said just now, counter movement jump, you are starting like this. It's very important to remember, okay? So later when you see the practical, I want you to think about this and apply it to the practical. And squat jump, you're jumping like that. And all right. So when you get results from the counter movement jump, you will be able to see that most of the time, your counter movement jump will yield a greater height. So let's say, for example, if I jump 100 centimeters on a counter movement jump, my squat jump should be lower than the counter movement jump. Does that make sense? Let me explain why. So the counter movement jump is maximizing the stretch shortening cycle. So like I said, counter movement absorbs the energy and then converts it into power. Squat jump has no energy to convert at all. That's why it is harder to go higher. So later you will see why. You can actually see it happening. So in the event, let's say you do a test on a person and the counter movement jump and the squat jump are actually the same result. So they both jump the same height. It could actually mean that this athlete in particular is either not efficient in converting energy, or so it could be either one or it could be both, or he just doesn't actually know how to jump properly. So his technique of jumping is not well versed and he actually has to practice more on that. All right, so the other jump is we're talking about drop jumps, right? So drop jumps test explosive power, which is pretty much what all jumps do actually. So there are two types of drop jumps. There's the bounce drop jump where you jump off a box. So let me just show you what a drop jump looks like. All right, so a drop jump looks like this. You start on the box, and then when you are cued, you land, you drop off the box onto the floor, and then jump up as high as you can, and then land again. So the bounce drop jump test is what you guys have just seen, where it was off the box onto the floor, immediately up into the air. And then there's also a counter movement drop, which is the same thing, except when you are here. So after you've dropped down from the box, you actually go into more of a squat, and then only you jump up. So when you do the counter movement drop jump, it actually involves a larger downward movement upon ground contact. You are absorbing more energy so that you can jump higher. Oopsies, sorry. Okay, so what we have done is that we've actually conducted a study on drop jumps. So the drop jump that we use is a Comey and Bosco drop jump, which is the bounce drop jump. So minimal ground contact time. So it's like you're playing the floor as lava. And this drop jump emphasizes on a short ground contact time. So that means you have to minimize knee and hip flexion. So by doing that, you actually have no choice but to enable a very fast, very quick stretch shortening cycle, especially in your Achilles tendon from the muscular tendinous units. So the drop jump, this drop jump that we want to focus on encourages the SSC muscle activation when you are placing a supramaximal load onto the joints. So supramaximal as in more than your 1 rep max, which is your body weight plus gravity upon landing. And this is most applicable to track and field. So this one, the bounce drop jump, is most applicable to track and field as opposed to the counter movement drop jump. Because when you run, you skip, you hop, you rely on fast movements. You don't have time to absorb a lot of action. And we rarely ever use one type of muscular contraction alone anyway. So the application for these drop jumps in track and field is that a lot of events actually do require this particular movement. So you can use drop jumps as an exercise, you can use it as a measurement tool, an injury risk assessment. Let's say, for example, if you compare left leg and right leg, you actually may find that, let's say, the left leg does better than the right leg because the left leg has a shorter contact time and a higher jump height. You can also use this as a return to play testing protocol, which is what we've been doing with the paper that I mentioned that we wrote, that we want ideally this to be included into our return to play testing protocol. All right, so how it starts is that the first phase is the step up phase where you're on a box, arms on your hips, and you're hanging 1 foot off the box. So the reason why you want 1 foot to hang off the box already is that you help the participant just sort of fall off the box. If you have 2 feet on the box, the participant has a higher chance of jumping off the box, which is not what you want. Also, of course, you have to make sure that the participant is looking forward. And then upon contact phase, which is known as the ground contact, you want as short of a contact time as possible. You don't want to stay on the ground too long. So you don't want to allow ankle, knee, and hip flexion to flex so much. You also obviously have to ensure that the participant looks forward. If you don't look forward, if the participant is looking down, your jump height, his or her jump height will actually be significantly lower. All right, and then this is the takeoff phase. So this is where you push off the ground and go into the air, which is your flight time. So ideally, you want your flight time to be as long as possible. So there are two things that influence the flight time. Obviously, is how much power you have in your lower limb and also how strong your core is. So the stronger the core, you'll be able to have a longer flight time because you'll be able to hold yourself in the air longer. I mean, it's not to say a whole second longer, but even 0.01 of a second is valuable enough in high performance sport. So of course, you want to establish triple extension for this because you have to contract all the muscles to propel yourself forward. The participant, of course, cannot tuck the knees in, so you don't want any form of knee tucking because that's cheating. And maintain hands on hips. So the reason why all the 3 jumps have hands on hips is because if you allow the participant to use the hands to swing, there is counter movement there on its own. But we don't want any help aside from the lower limb. So we have to omit the counter movement from the arms. So the aim is to obviously jump as high as possible to increase your flight time. All right. So this is your final landing. So this is the landing after you're in the air and you fall down, you reach the ground. Of course, you want a soft landing. You want the knees to be above the ankles. So you don't want the landing to be what I explained to you just now in the squat jump. You want the landing to look like this. You want to absorb the landing before before standing tall. Oopsies. All right, so how do you assess and make sense of all the results from the jump test? So are there any differences between the jumps? So like I said, ideally you would expect your counter movement to be higher than your squat jump. If it's not, why is it so? So if let's say it's not within the 20-30% difference, is there a reason why there is a difference? Is it because someone cannot jump as high? Is it because he's injured? And then if you do a single leg test, which is pretty much, okay, so this one, it was the contact phase, you land with one limb. If you do a single leg test, you land with two limbs. If you do a single leg test, you're only landing with one limb. So if you compare left and right for the single leg drop jump test, is one leg jumping higher than the other? Is one leg spending more time on the ground? So you can use this one as a performance test and two as a return to play test. So the reason why I say that this test is important for return to play is that a lot of return to play tests involve strength tests. So let's say you injured your lower leg and you go for physio, you go for rehab, and your strength test when you check individual legs is that your left leg and your right leg can push on its own 100 kilos on each leg. So you think that they're okay to go back to play, right? Because the strength is equal. But when you do the single leg jump test, maybe the injured leg could have a longer contact time and a shorter flight time, which means that they're not ready. They need more plyometric exercises to return to sports, because track and field is one of the most explosive sports in this world. So you can't just let them go back to play just because you think they're strong enough, because strength and power may have some overlap, but it's not the same. So you need to think, were there any pre-existing injuries when you are doing this test? So when I was talking about the test, usually you would be using like a force platform or a contact mat, but all these things, they just give you numbers on how they perform. What you also need to see is how they land, how they jump, and stuff like that. So right now you can you can use any phone, any Huawei, Oppo, Samsung, iPhone. They all have slow motion cameras, so you don't even have to buy a fancy camera. You can just use your phone, and you can actually watch if they do any unnecessary movements, if there are any wrong landings, improper techniques. So depending on the result, it's possible to assess if the issue is regarding a lack of strength, a lack of technique, and stuff like that. So usually the apparatus you use for jump test is a force platform and a contact mat. But not everyone can afford it. Not everyone can lug it around onto the field. So what you can do is you can use a slow motion camera. You can use a vertex. You can use the chalk trick on the wall, where you stand next to the wall, go into a squat, jump up, and then extend your hand as high as you can and try to draw a chalk mark on the wall, so that it gives you a rough idea on how high a person has jumped. It may not be as accurate as a force platform, but it is much cheaper, more conducive, and you can do it anywhere. So just now I briefly mentioned that there's vertical and horizontal jumps. So the horizontal ones are hop jumps, which is basically broad long jump test, or the single leg triple hop. So doing a jump test jumping vertically up is not enough, because you also need to see the forward explosive motion, because most events are all forward explosive motions, right? So a broad long jump test is basically you stand at the starting line, feet shoulder width apart. This one, you don't have to keep your arms on your hips. You can actually swing them around to give you more of a jump distance. And then when you're instructed, you want to go bend your knees into a squat, and you want to drive forward as far as you can. So the goal is that you want to cover as much distance as you can. So the further the distance covered, the more explosive you are. You can also test it with a single leg triple hop, where you can also assess power. So basically you stand on one leg on the starting line, and when the assessor says go, let's say you start with your right leg, for example, you take 3 hops with your right leg consecutively, so no pausing at all, without falling, keeping your balance, and you want to jump as far as you can. So you're hopping 3 times forward. So this one you could actually assess also with distance, obviously. You can assess it with the slow motion camera to see how each individual single leg landing varies, and you can from there figure out why they vary. And you can also compare like a dominant versus non-dominant leg, or a leg that's more injured, also a leg that is at a higher risk of injury, because you can compare the left leg and the right leg, see how well they can do. All right, so the last one is this, no, almost the last one that I'm going, oh, it is the last one that I'm going to talk about is the quarter squat. So a lot of people, they tend to conduct a squat test, 1 rep max squat test. So in a squat, a lot of muscles are involved. You've got your quadriceps, you've got your hamstrings, calf, core, glutes, everything. Well, what a lot of people overlook is a quarter squat. So the depth of a quarter squat is obviously a quarter of a full squat. It's given in the name. And the reason why we want to highlight this quarter squat is because this quarter squat involves the VMO more. So VMO is your vastus medialis, which is the teardrop shape on your quadricep that everybody likes so much. So the VMO is most active in the last 20 to 30 degree of knee extension, which is pretty much the quarter squat. So the VMO plays an important role in patella movement. So if there are any physios here, and if you notice, if you've had many patella maltracking patients, you would notice that the maltracking usually is towards the lateral side due to weakness of the VMO. It's very rare that the maltracking is more medial. If it's more medial, that means the VMO is obviously tighter and you have to release it. But ideally, you want a stronger VMO in order to avoid patella maltracking laterally. Okay, so that is all that I'm covering for today. You guys will have to keep all of this in mind, and when you watch the practical session going on, you will be able to understand more what I'm talking about, all these cues and how to tell what is strong and what is weak. So if you have any questions, you can email me at this email.
Can have some questions. We can have
Oh, okay, yeah, you can have a few questions now if anyone wants to ask anything.
All right, participant, if you have any question, just direct ask question. Anyone? Mejo, you want to ask question? Yeah, okay, please. Your mic is echoing.
Yeah. Actually, there's a question from Mr. Pawisitang. He said about his athlete. Normally, he just walk, but they got swelling, without any contact, but it swell. Do you have any idea what is happens to it? They just walk.
Okay, so even with walking, his knees swells up.
Yes.
Okay, so there's a lot of reasons why the knee could swell. Obviously, it's injured. Why it's injured, you have to actually test. So is there any pain or is it just swelling?
It's just it's no pain, it's just swelling.
No pain, just swelling. All right, so it could be that there is something going on within the knee that is aggravating something in the joint. So there's a lot of tests that you can do, but this is quite a difficult question to answer because there's a lot of questions that like I need to know whether he's been previously injured or how he walks. So you can actually check how he walks, and it depends on what sport he does also. if let's say there are any pre-existing problems going on inside the knee. All this you actually need to know before finding out why it is always swelling.
Okay, thank you.
Yeah, so it's quite hard to answer that.
Any other?
Good morning, madam. I have a question regarding the energy source which was explained in the stress shortening cycle.
Yep.
You have explained the energy source of 3% of sprinting. The ankle energy source will be ankle energy source will be 34%. Hip extension will be 24, and leg flexion will be 25.
Yep.
If we compare the velocity, if the velocity increases, what will be the energy source difference? Is it the same, or the energy source of energy expenditure of the ankle will be more if the velocity is getting increased?
So if the velocity increases, the energy source will transfer more towards the hip and the knee and go less towards the ankle. But you need to remember that the ankle is the first thing that hits the ground. So it gets most of the ground reaction force, and it's also very small compared to the knee. It's very small compared to the hip. The muscle controlling the knee and the hip, they're very big and they're very easy to train. So when it's easier to prevent injury for that, because number one, the knee and the hip are further away from the ground, so ground reaction force has dissipated to the knee. Number two, the muscles protecting the knee and the hip joint are much bigger, much easier to train, so the risk of injury is also lower. But when it comes to the ankle, tendons are the only things that go through it, ligaments are the only things that go through it. So the energy source from the ankle will decrease with speed, but the ground, so we're not talking about energy source as a whole, as in general, just ankle. We are comparing from 100% which part the body will focus the energy source on. So they will take from the ankle and pass it to the knee, pass it to the hip as speed increases, but that doesn't mean that the impact into the ankle is any lower. It's actually much higher with velocity.
Yeah, I just want to clarify that the energy production during the slow speed for the ankle was 34%. If it is if the velocity increases, if the energy source of the hip flexion or hip extension will be increasing, can you elaborate that how much percentage of the extension will be increasing, so that we can concentrate more on the hip extension posterior chain exercises for the athletes?
Oh, okay. So you want to know how much more energy source is given in the event that the velocity increases.
Yes.
Okay, so that one is actually quite difficult for me to answer, because the numbers that I gave you was conducted, a study was conducted. So they limited they controlled the speed at 1.2 meters per second, 3.2 meters per second, and 3.9 meters per second. So this number is what the study gave. If I were to give you a number, I cannot give you a specific number. All I'm able to give you is that the hip extension and the knee flexion, the body will transfer more focus, more of it as the speed increases, but the impact towards the ankle will definitely increase.
Thank you, madam. Thanks a lot for your answer.
Oh, whoa, what's this? Oh. What do I do?
Well, you have to do it later.
Okay, so when the athlete works so hard for the training with right technique, does it affect the muscle or bloodline between hip?
Make this later.
Oh.
Too long. Too long.
Okay.
Yeah.
All right. So
tell them. Yeah. Well, I will tell them.
Okay, we are running out of time. We are going to do the.
You can answer the question, but it's just too
Oh, okay. Okay, so there's a question on.
Yeah, on the chat room. I want to show the question in the chat room, but I was wrong.
Okay. So when the athlete works so hard for the training with right technique, does it affect muscle or bloodline between the hip and legs? If not right tech, okay. So this is the answer that I will give you is very long. So is it okay if I email you the answer instead?
Okay.
Yeah, because I don't think we have time for me to answer. This is like a whole lecture worth of answers.
Okay, I think we can answer later.
Yep.
So we still have 30 minutes, but you have any other subject to York?
Yes, wait, I'm coming.
Yeah. Okay.
Because we are out of I'm here, so I'm not running away. Yeah, no. Thank you very much, Rachel. I guess was a great lecture for you guys. Yeah, when you see rehabilitation and biomechanics is very similar, you need a lot. Yeah. So my idea is now what we are doing. We're giving you some examples how to do it and how not to do it, and how you can see a lot of things, yeah, easily with your eyes and with the camera, etc. So we have some examples for you guys to see what's going on, what we saw with our people. This is the plan for the next 25 minutes. Then we have our break, and then we're coming to the testing, goal setting, creating training schedules, etc., etc. That's the plan. Yeah.
Okay.
Okay.
Yeah. 5 minute coffee time, then go back.
Okay, 5 minutes coffee time. Yeah, or break. Better. Okay. So yeah, see ya. 5 minutes. Yeah. No, it's maybe this one. No, it's the same. Because you see more our rear mate than us, but it's okay. It's fine. It's much better. All right. So let us come back. So testing and biomechanics, we realize, and rehabilitation come together. So what I want to do now, I show you some examples what we are using every time to show athletes what is wrong, what is right. And first of all, what I want to discuss with you is we have every time issues for athletes and coaches to understand. No, you can talk. What means
your connection is okay.
What means dominant and non-dominant? What is your dominant side and what is your non-dominant side? There is a lot of discrepancy about this, and it is very easy to check out yourself. So what I want to do now with you guys, you stand up in your living room, you stand in front of the mirror or somewhere else, you jump straight up and you turn 90 degrees. And you let me know on which side you're turning. Okay? Check that out. I give you 30 seconds and you have to be finished. Don't forget to turn. You have to turn 90 degrees. You jump straight up and you turn 90 degrees or 180 degrees. So you jump up and then you turn. Don't forget. Okay, good. So I'm sure most of the guys turning to the left side. Yeah? So that means your dominant side is left. And it's very simple. Why? Because you have much more confidence on this side. People say this is not true. I say it's very simple for me. When you shoot a football, you will shoot with the right leg, not with the left leg. This is true. But where you stand, on which leg, when you kick the ball, where is all the force going? This is the left side, not the right side. The right side had maybe much more power and much more strength, but it's not your dominant side. The dominant side means where I have my confidence. Yeah. And a lot of people, when we did our research project, said, oh, my dominant side is right. I said, you're sure? Yes, I kicked the ball with the right side. I said, yes, you have much more strength. But your confidence is on the left side because we are diagonal. Most of the guys are right-hander. So everything going to the left side. Yeah. When you know that, it's very important for you when you do your testing to realize that. Because it's every time a different stuff between the dominant and the non-dominant side. Yeah, please bring this inside your mind and don't forget it. It's very important. There is a lot of controversy about it, but for me it's very simple. When I jump and I jump to the left side, my confident side and my dominant side is left. It's very simple. Yeah, because I can move. I'm not looking to the right because I'm scared. Because I can't. You check it out. It's very tough to jump to the right side when you're dominant left. It's not easy. But opposite, we have a lot as well. Yeah. Think about your left-hander. They are maybe dominant to the right. 20% of the guys also, they are right-hander, but the dominant side is right because they have more confidence. Maybe something was happened. But we have very good experience when we say the dominant side is this side, jump and turn. You check it out yourself with your athletes, you will see it's funny what the people say to you. Yeah, or most of the guys say my dominant side is right. And then you say, okay, you check it out. Where is your confidence? How you kick the ball? Funny part is for me, think about long jump, high jump. Guys, think about high jump or a long jump. When people tell you my dominant side is right, why are you doing long jump or high jump with the left leg? Yeah, hurdles. Why the takeoff is left and not right when you say my dominant side is right? Makes no sense. Yeah. Think about yourself when you step up the stairs. How you step up, which leg is in front, which leg is in the back. For me, every time my right leg is going in front because I'm left dominant. I have much more confidence in my left side than to the right side. But I'm kicking the ball with the right side. Yeah? So think about it, change a little bit your mind and find it out. So we still have 10 minutes. I will go now for some videos, what we did with some athletes that you can see, what you can watch yourself. Yeah, what might be wrong with your athletes, maybe with the strength. Maybe we are doing a lot of strength training, but not the right strength training. And this is easy when you can see. So what we did, we use a very simple slow motion camera to show our athletes or patient what is wrong with them. Because a lot of athletes say, I'm fit, or but we realize it's not the case. Yeah, so enjoy the videos. I will explain a little bit, and you have any questions, let me know, okay? Wait a little bit because we have some difficulties. Yeah. So the first test, what I like to do, especially when it's coming to return to sports, is the single leg stand and sit. It's like a half squat, but we are doing this with one leg. We do later also a little practical stuff to see the strength. Is it possible? We can do it. Yeah, with two legs, yes. But when you are injured, what you will do? You will shift every time to the non-injured side. And you have to think about it when it's coming to return to sports. This is not what we want. We yeah? You're done? Not yet, huh? Okay, we still have to wait. So when you see this athlete, what he's doing, yeah, I want you that you watch, and then you can see, oh my God, he's shifting every time to one side, or he's shifting with his upper body, what is totally wrong. So he don't have the confidence, yeah, to do this easy single leg stand and sit. Coming. Aha. Nice communication. Share. All right.
Okay, finally.
Yes, happy. I'm happy as well. Okay. So, check the video. Hanging. You can see this is the injured leg, yeah? But also on the right side, on the left side, you have some issues. Look, and now you have to think, we are talking about actually easy exercises, yeah? And we can't see that every time, and you see here how difficult is it for him to come up. So his strength is not enough, especially when we are coming to the hamstring, yeah? So we have one more, and this one, after a while, because he did it quite well, it looks much better.
That's a very
Yes, but it's good. So you need also a little bit training for this. And now we are coming back. Strength is very important, and you can see, we can say very clearly, he is not ready actually to go for his normal training. He still needs more rehabilitation. That's the next one. And then we are coming to the drop jump, what Rachel was explaining. So you see that. Look in his left leg, what he's doing. Wait. Sorry, we have to do it one more time. Okay. It's not slow enough. So you can't see it clearly. The next two are, I hope so, it's better because it's the single leg.
too slow for the PowerPoint.
Oh, okay, that's too slow for the PowerPoint. Go to the next one. Oh, doesn't work with PowerPoint. Next time we have to do something else. To the next one, what's coming? This is actually a good one. So here you can see, I hope this works much better because yesterday it was working.
It's going to be the same like this. So show it for me. Okay. Which one you want to show? This one?
No, I want this
single
one.
leg.
This one. Yeah. No, this one, the first one first, not the second. Okay. So look what he's doing, yeah, with a simple squat jump. You realize that he's actually a little bit cheating because a squat jump, yeah, we want actually only that he goes straight up, but he's moving forward, yeah. But this he can do, yeah, with 2 legs. The next one, yes. So he's still cheating, and it's not bad what he's doing, yeah. We come into one more. So now the counter movement. Good one. Okay. Get out. Back to our room. Yes. So you saw we have to look inside a lot of things when it's coming to rehab, yeah, especially the testing. And a lot of people don't see that. But for us, it's very important. We are dealing one more time with our national athletes, top athletes. So they need good care. We don't do it, they get injured again. So it's our job to bring them back perfectly. Yeah. So it's 12 o'clock already in Malaysia. So any question, let me know. When not, we see you 2 o'clock Malaysian time. And then we are doing, yeah, the testing and creating programs, how we do it, how we set goal setting, etc., etc. Okay. I hope you enjoy it. Yeah, I like it very much. And we see each other in 2 hours. Yeah. Miss Ria, anything to say?
No, Pak Yorks. Okay, so everybody will see you again at 1 o'clock Indonesia time or 2 o'clock Malaysian time.
Okay. Jumpa lagi.
Ya, jumpa lagi, Pak.